Okay, a very good day to all of you. Today we are going to learn the line integral of vector field, which is in the form of the line integral of f dot dr along the curve C, where the f is actually a vector field consists of mi plus nj plus pk, where the m and p is a scalar function of variable x, y, and z. And let C is a smooth curve defined by RT equal to the XTI plus YTJ plus ZTK, where the T from A up to B. Okay, from RT you can find dr dt, okay, dr dt, and bring the dt to right side to become dr is x prime ti plus y prime tj plus z prime tk. Hence, to evaluate the line integral of vector field, okay, we plug in the vector f dot with the dr, and then we may evaluate this one, the dot product first. We thought everything in terms of t, and then we integrate respect to t from a to b. And then you notice that the line integral of vector field actually, when you expand in the vector f dot with the dr, okay, dr is actually from r we have here RT is xti plus ytj plus ztk. So dr actually you have x prime t or dx dt I plus dy dtj plus dz dtk multiplied with dt, because naturally dr dt dr you bring to right hand side, and then if the dt and dt here cancel, it become mi plus nj plus pk dot with dxi plus dtj plus dzk, okay, the dot product, okay, is it component I multiplied with I, so mdx plus, sorry, this is y, ndy plus p dz. Hence, you can notice that the line integral of scalar field is actually equivalent to the line integral of differential forms. Okay, next step to evaluate the line integral of vector, vector field is actually change all the function m and p in parameter t, then finds the dr. Third step, you evaluate the dot product, later on integrate respect to t. Okay, for example 1, evaluate the line integral f dot dr along the curve C if given the vector field f equal to x plus 3yi plus 3x plus yj, and the rt is ti plus t squared j, where the t from 0 to 1. Okay, first of all, from the f here, and then from the rt, we know that component I is actually x. So component j is actually y. So mean x is equal to t, y is equal to t squared. Once you replace x here by t, y by t squared. So component I for vector f becomes t plus 3t squared, component I. For component j, replace x by t, so you have 3t, replace y by t squared. So this is t, this is t squared. So you have 3t plus t squared. Okay, x is actually t, y is t squared. So you have t plus 3t squared. For component I, component j is 3t plus t squared. Okay, from rt, we find dr dt, we have I plus 2tj, and then dt bring to right side, so become I plus 2t j dt. Hence, later on, third step, you find the dot product f dot dr. Okay, taking the f dot with dr, call back the dot product, the result is the scalar, where each component I is multiplied with I, j with j. So t plus 3t squared, multiplied with 1. So it's here, t plus 3t squared. Okay, later on, so it takes 3t squared multiplied with 2t. So it's 6t squared plus 2t cubed. 2t cubed. Then this is how we do the dot product. Component I multiplied with I, and I dot I have 1, j dot j have 1. Okay, simplify it. We have total 2t cubed plus this new term 9t squared plus t dt. Okay, fourth step, the result of f dot dr, we have here 2t cubed plus 9t squared plus t, okay, dt, then integrate, okay, respect to t from 0 to 1. So integrate 2t cubed, we have, okay, 2t power 4 divided by 4, simplify t power 4 divided by 2. This is 9t, okay. We have got totally 9 3 cubed. Then we have 9 3 cubed. When you integrate here, 9 3 cubed divided by 3. So you get 3t cubed. Okay, so integrate t squared over 2. Plug in the upper limit, okay. Plug in lower limit, you get everything 0. So simplify it, you get the answer is 4. Second example, same thing, evaluate the line integral f dot dr, given the f is zi plus xj plus yk, and rt is cos ti plus sin tj plus tk, t from 0 to 2 pi. Okay, from the rt, cos ti plus sin tj plus tk. Okay, and notice that, okay, actually from component I, this is actually x, so x equal to cos t. Component j is actually the y, so y equal to sin t. Component k is actually equal to z, so z equal to t. Okay, and then from rt, okay, you find dr dt, and then, this one, yeah, dt, yeah. Because dr dt is negative sin ti plus cos tj plus 1k, and the dt, if you bring to right hand side, become multiplied by dt. Okay, and then plug in the x, y, z into the vector value, the vector f. Okay, vector f here. So z is t, x is cos t, the y is sin t. Okay, later on we evaluate the line integral f dot dr. So this is a vector f, ti plus cos tj plus sin tk, dot with the dr, okay, obtained here, dot with the negative sin ti plus cos tj plus k dt. Okay, and then we do the dot products. Okay, component I multiplied with I, you have negative t sin t. Okay, and then component j with j, so you have plus cos squared t. Lastly, component k with k, so plus sin t. Okay, when we evaluate the first term, we get this one, you have 2 pi, cos squared t, we get pi, okay, sin t, we got 0, so total answer is 0. Okay, later we are going to go in detail, okay, how we get the integral of negative t sin t, the result is 2 pi. Okay, the integral of negative t sin t, okay, can be done using the tabular method, where we start, okay, the sign always start from positive, negative, positive, alternate. Okay, we have the product form of polynomial and sin t. We always choose a u as a polynomial. Okay, for u is actually will, okay, differentiates until we can get 0 if the u is a polynomial. So you differentiate negative t, you get negative 1, differentiate negative 1, you have 0, then we stop at this line. dv is actually the sin t. For dv, we integrate it. Okay, so integrate sin t, you have negative cos t, integrate cos, negative cos t, get negative sin t, and the result is actually, okay, follow the slanting arrow that I draw here. So you have positive times negative t times negative cos t, that's why I have t cos t, and then negative, negative, negative 3, okay, so negative sin t. You get here, actually, negative sin t. In this, okay, this one I'm using by part. Okay, if using tabular, straight away you get the result is actually t cos t. Okay, this one. Sorry. The first slanting arrow, negative, negative, positive, t cos t here. Okay, and the second result, this is actually negative sin t. So this is using, okay, by part, you need to, okay, do twice here, integral. If you use tabular, straight away you get this result and this result. Okay, evaluate the integral, okay, the result integral t cos t from 0 to pi. Okay, we have the result is 2 pi cos. Plug in here this 2 pi. Cos 2 pi is 1. Cos we have, okay, the result, okay, cos 2 pi is 1. This one. Okay, when you plug in 0 times anything you get 0. That's why this, okay, integral we get the answer is 2 pi. Okay, and then minus, okay, here negative, so minus sin t. So when you plug in, okay, 2 pi into sin t, sin 2 pi is 0, and then sin 0 also 0. Because sin 2 pi you get 0, and then sin 0 also 0. Okay, that's why the first result here we have 2 pi. For the integral negative t sin t we get, okay, the answer 2 pi. And then for the integral cos squared t, we may change it become half of, okay, half of 1 plus cos 2t. Okay, and then integrate 1 we get t, integrate cos 2t, cos sin 2t, divide by 2. Okay, plug in limit from 0 to 2 pi. Again, so plug in here. Then you plug in, okay, this one sin 4 pi is 0. When you plug in 0 to both t and sin 2t, you get 0. That's why you get here 2 pi divided by 2, which is pi. Okay, this is what the second result. Okay, here we get pi. Okay, lastly, integrate sin t from 0 to 2 pi, you get the answer is 0. Because integrate sin, okay, we have negative cos t. Okay, however, cos 2 pi, the answer, okay, cos 2 pi, the answer is 1, cos 0 is 1. Okay, so you get 0. Okay, or you may straight away, I think, use a scientific calculator to evaluate it. Okay, example here, and I'm in radian modes already. So you integrate, okay, of course, in scientific calculator, the integral is in variable x, then you have to change the t into x. So negative alpha x sin alpha x. Okay, I have plus cos squared x. So I make a bracket. Cos alpha x plus it, I square it. Okay, and then plus sin x. And then from 0 to 2 pi. Let me check. Negative x sin x plus cos x open close. And then plus sin x. Oh, missing one bracket. Once I open the bracket here, I have to close it. So the answer 3 pi. Because just now I opened this bracket, I missing one bracket, one closing bracket at here. So the answer 3 pi. Okay. Now, okay, we would like to view what's the meaning of the line integral of vector field. As we learned in the previous lectures, the line integral of scalar field represents the mass k of a thin wire. Okay, and what's the meaning of the line integral of vector field here? Okay, let's say this is a vector f, and this is a vector f making an angle theta with the direction of the movement here. Okay, direction of movement. Okay, and this is along the curve C. Then we have the consider an object moving along a path C in the force field F, and a unit vector, a unit work, okay, delta Wi is actually, we have the force multiply the distance, and the force is actually because it's, okay, the F here, the projection of the force, okay, will be Fi cos theta I, mean the projection of F along the direction of movement. The distance is actually the delta Ri. So F dot delta Ri is actually F dot delta Ri. So this is become the, okay, yeah. So this is one unit work. Okay, if we have a total work, okay, means we are sum out, okay, summation, where the Fi delta Ri I from 1 to n, where the n approaches infinity. Okay, this will be equal to the line integral f dot dr along the curve C. So means the line integral of vector field represent the work, okay, done by the vector field, okay, f along the curve C, along the curve C. So example 1, find the work done by the force F x cubed y I plus x minus yj to move an object from the point negative 2, 4 to 1, 1 along the parabola curve y equal to x squared. So in this case, okay, this example not like the previous two examples where the, okay, RT is given, but here they will, okay, given the, okay, force F actually move an object from the point negative 2, 4 to 1, 1 along the parabola curve y equal to x squared. Then you need to, okay, you need to specify your own parametric equations or the vector RT. Okay, from y equal to x squared, as in the previous case, line integral of scalar form, okay, or differential forms are already mentioned that if the, okay, parametric equation is not given, then, okay, from the variable at the right hand side, okay, you may let it equal to t. Easy, you let the x equal to t, then y will be equal to t squared. Since x moved from negative 2 to 1, hence t also moved from negative 2 to 1. T also equal from negative 2 to 1. Okay, and given the f is x cubed yi plus x minus yj, so if plug in x is t, y is t squared. So t cubed multiplied t squared. So for f total you have component I is t power 5. T power 5. Okay, plug in x here is t, y is t squared. For component j you have the t minus t squared. So t minus t squared in component j for vector f. Okay, and put in the parametric equation for x and y in vector value functions rt. Okay, component I is actually the x, so rt is your ti, component j is actually your y, so plus t squared j, t squared j. Okay, and your t from negative 2 to 1 because x equal to t, x equal to t, and x from negative 2 to 1, hence t also from negative 2 to 1. From RT, you find dr dt will be 1i plus 2tj. Means dt bring to right hand side become dr will become I plus 2tj. Okay, whole thing multiplied by dt. So the work is actually equal to the line integral f dot dr along the curve C will be equal to the f that we obtained here. This is f dot with the dr, which is I plus 2tj dt. Okay, and then we find the dot product first. So total this is t power 5 multiplied 1. So t power 5 components, okay. And then later on take component j multiplied with 2t. So you have 2t squared minus 2t cubed. Later on integrate respect to t, substitute t from negative 2 to 1, you get the result here is 3. Of course, okay, you can directly using your calculator and you should get this answer. Okay, let me check it. So again, integrate. We have a, okay, alpha x power 5 plus here plus 2 alpha x power squared. I got mistake this one. I'm going to put this one first. So this is negative 2. But I'm going to, okay. Okay, 2x squared minus 2t cubed. 2 alpha x cubed. Okay, close the bracket. Okay, answer is 3. That's what you obtained manually. In the last example, finds the work done by the force field Fxyz equal to negative half xi minus half yj plus 1/4 k on a particle as it moves along the helix given by rt equal to cos ti plus sin tj plus tk from the point 1, 0, 0 to negative 1, 0, 3 pi. Okay, from the vector f here, okay, this case is easy because RT is given. Okay. So from the RT, you find the dr will be negative cos Ti plus, dr, differentiate cos T, you have negative sin Ti, and then differentiate sin T plus cos Tj, differentiate T, so plus 1k, okay, dr, and then I should have the dt. Okay. And then from the point 1, 0, 0 to negative 1, 0, 3 pi. So you want to evaluate f dot dr. So this is a dr here. Negative sin Ti plus cos Tj plus k dt. Okay, and then you plug in here. From the RT, component I is actually this is x, component j is actually the y, component k is actually the z. Okay, so the x, okay, x here, you plug in with cos t. So y, you plug in with sin t. So that's why with vector f, you have negative half cos t, okay, and then component j, negative half sin t. Okay, component k is constant, component t, okay, component k is 1/4 constant, 1/4. Okay, later on you do the dot product here. So negative half cos t times negative sin t become positive half cos t sin t. Okay, component j is j, so negative half sin t cos t. So component k 1/4 times 1, 1/4. So this one and this one cancel. So it's just left, okay, integral of 1/4 dt. Okay, integral of 1/4 dt, you have t over 4. Evaluate it from 0 to 3 pi. That's why you get the answer 3 pi over 4. Okay. So I conclude back in this lecture. Okay, is the line integral of vector field, okay, given by the integral f dot dr along the curve C. This line integral of vector field, okay, represent the work done, okay, by vector, okay, field f to move an object along the curve C. To evaluate this line integral of vector field, okay, plug in, okay, your vector f. This is consists of mi plus nj plus pk. Then dot with the dr. From rt, you find the dr dt. Later on your dt bring to right hand side, so you get your dr is actually x prime ti plus y prime tj plus z prime tk dt. Then you evaluate the dot product. So we left a function in terms of t. Lastly, you integrate respect to t from a to b. Okay, sometimes if the equation is not given directly in a vector field, okay, in the RT form, then you need to find, okay, your own parametric equation x, okay, then component x, you put it into the I, the equation y you put as a j, Okay, component K, Z is put in K, like this example. This one. Along the curve y equal to x squared. And then you let x is t, y is t squared. Then your RT. Okay, component I is actually parametric equation for x. Okay, component J is parametric equation for your y. If the component K is parametric equation for z. Okay, with this, thank you for your attention and watching this video.